Welcome to all. In this video, we will discuss about the first law of thermodynamics. Before we going to that, we know about what is the principle of thermodynamics. So, the principle of thermodynamics is the heat energy is converted into mechanical energy, and finally it's converted into electrical energy. So, here the principle of thermodynamics is, before we discuss about the objective of in this video is the human beings obey the first law of thermodynamics, and the first law of thermodynamics gives a practice definition of heat, and the ideation of the concept is the first law of thermodynamics, and the first law of thermodynamics in a nearly is an independent ideal gas system. As the introduction of this in this video is thermodynamics is the branch of physics that deals with the relationship between heat and other form of energy. And first law of thermodynamics states that the heat is a form of energy, and thermodynamic processes are therefore subject to the principle of conservation of energy. And it means that heat energy cannot be created nor destroyed. The fundamental principle of thermodynamics are expressed in four laws. Can, however, be transferred from one location to another and converted to and from other forms of energy. And first law of thermodynamics is the first is work is the total energy heat transferred to a system by macroscopic forces exerted on it by other system, and the work is integral of force with respect to the direction. And in this equation is the fluid gas properties, or it is moved with the net work done. And the work done of fluid, it expands is the energy leaves of the system to the energy feeds in the system. And examples of first law of thermodynamics is here is located, and it's option A and it's option B. And it's option A, it's in internal heat energy is transferred to the net heat transfer with respect to the work done. And del U with indicate is the state of stored of the food energy. And so next we will discuss is an working principle of thermodynamics. So it is a working principle of engineering thermodynamics is located, or we can assume is in a control volume of the force. So in this control volume, it's two types of way is the inside part, and its one is the exit part. And the inside parts is the energy being transferred into the system, and the exit is the energy being transferred outside of the system. And the net heat transfer is equivalent to the net work done with respect to the time and the energy added to the system. So in it's the energy being transported out of the system. And the experimental and the results of state 1 and state 2 is represented is in a Q is in a heat transfer and will transfers to the work, and A is the internal energy of the system. So it is the differentiate between E2 and E1 with respect to the net heat transfer and net work output. So for this law of thermodynamics, the energy released from somebody source, or it's equivalent to the some other of energies. So this is the assessment part of in this video lecture series of first law of thermodynamics is the first question was, which of the following is true about a reheat cycle? So the option A is a turbine exhaust as 0.85 when steam pressure is higher than maximum. And after partial expansion in turbine, steam is brought back to boiler, and the steam is reheated by combustion gases. And this is in all the above. And the second question was, what is the correct sequence of expansion in reheat cycle in heat pump turbine? It's a constant pressure in boiler and low pressure turbine. And third one is in what is the right the use of the first law of thermodynamics. So this is a little bit introduction about the first law of thermodynamics and how it will be adapted in aerospace applications. Thank you.